ramp that the cars come down. Just goes on and on. And on a sunny day, all you see is like a heat haze shimmer. You can see how flat it is. Actual photo of a P38. There is the belly tank, you see, and you can have one the other side too, so it just gives you loads more range. An accurate scale model which sits here. This is a scale model to scale of me, which was made from a set of photographs using photogrammetry sitting on my driveway, and here is a flathead engine. Now you notice the engine goes behind the driver, there's no prop shaft, the engine bolts directly to the rear differential basically, with an adapter that you have to make, and it's like a Formula 1 layout. When you buy something like this, there are no guarantees at all. The block could be cracked, who knows. I've seen a video of this engine running in 2015. I've seen another video of it running in 2019. And prior to that it was in a museum and had been running. So I've built a test stand. The engine and gearbox are at the exact height they would be if I had 31-inch diameter tyres on the rear. And you could say, well, what do you mean? The prop shaft allows you to have the engine a little bit higher or lower. Well, the reason is, in a belly tank racer, well, you can have a prop shaft, you often don't have a prop shaft. This female spline fitting here on the end of the gearbox will actually connect directly to the male input here for the differential if we get rid of this torque tube. It's a bit like when you learn to solder. It's actually easier if you use thin solder, you know, when you're soldering electrical joints. So I bought a whole load of these welding rods. They're actually, I think they're a little bit too thick because they take a little bit of heat to actually get them to melt. I think I'd be better off if I'd used the next size down, but you live and learn. Obviously all the wires are the same colour, it's quite easy to get it wrong. So I've labelled everything extremely well because I don't want to make any mistakes. You see how these two cross over. These pipes have holes in the sides, and although this engine was built to be affordable, you'll notice that they've taken the trouble to round off the edges. They haven't just cut holes here. If you look, they're rounded. I don't quite know how they've done that, so it doesn't chafe the wires. On now. So there we go. That's my oil pressure. This is a blanking plug. The other thing I've got to think about is the fuel delivery. So this is the fuel pump with a bit of bodgery to a boat tank system for a small boat with an outboard motor, and this also has a priming squeezy thing in it, which is quite helpful because I can hopefully prime the carb before I start the engine into the fuel pump. Kind of hoping it will. It should do. Yeah, promising. Top hoses with thermostats. I've got a cheap electric fan which I'm just going to cable tie onto the front of here or something. Not quite sure how yet. Not going to run the generator. I'm going to run everything off 12 volt 12 volt coil, which will be temporarily mounted somewhere. I've got an electronic distributor that's 12 volt. I've actually invested some money in that. And the starter motor, you would think you need to convert it to 12 volts somehow, but actually people just run them off 12 volts. So maybe I should keep the amount of starting down, stop it burning out, but in short bursts, that's okay. There's no gap. This has been bent over too much. Now, this engine was described as running a bit rough when it was last run, so I mean, probably wasn't firing on one of the 8 cylinders just there and then. The light right, you can see on the left, hang on, well, okay. On the right there's a valve and it's closed, and on the left you can just see the edge of the other valve, which also, in fact, if you get it, look, you can see it's open. The other thing I'm going to do is just put a little bit of oil down each of these plug holes. But some people use automatic transmission fluid. Some people seem to just squirt WD-40 down. But I mean, I think I'll just start with engine oil and see how I get on. I've seen every valve. These are my valves. This is cylinder 4, so I've got 2 valves, and I've seen them both open and I've seen them both closed. And the same for this one. Turn that the other way, so you're facing the side of the engine. Yeah, so every valve I've seen closed, every valve I've seen open, and the ones that are open I've seen close again. Put the switch on, that puts power to this button, and it also sends power to the plus of the coil, and the plus of the coil is connected to the plus wire, the red wire, to the distributor, and the black wire from the distributor goes to, this is a 12 volt system by the way, goes to the negative of the coil. Give it a squeeze. I'll also just listen as well, I might be able to hear it coming through. Yeah, you can hear the float valve sort of popping off. Hear that? Ooh. Right, there's fuel in the bulb now because the feel has changed. Ignition on. Starter on. Linkage here. 69. If your threads are a bit loose in your cylinder head, I was just wondering if there's any variation in the thread diameter. from one manufacturer to another. There's these short books by a guy called Vern Tardell, and in here, these are mine of useful information. It tells you how to take it off. So the problem is, I think, on the other end, on the engine end of the shaft, there's a speedo drive held on with 2 bolts, and I've got to take that off, and then the torque tube should slide off, leaving the drive shaft down the centre, still connected to the banjo splines. And you'll see there's like a pin that has to be driven out. There's a slot in here with the Dremel, with the cutting disc. And I'm going to use big hammer on an impact screwdriver with this bit in the end. Basically you hit it and it'll do a left kind of quarter turn. You hit it really hard, and it may loosen it. Twist it so anti-clockwise to take up the slack. Alright, and then you whack it really hard. See how it just, see how it's turning just a tiny bit? Oh, it's coming. Yeah. Ah, there we go. Oh yes, here it goes. A little bit more, a little bit more. Whee! Later in 1937 and onwards, they used a solid rod, whereas this is like a hollow tube. Well, this was my first attempt. I don't know if you can see, but it's a bit of a failure. I mean, that looks strong enough to me. That looks stronger than the commercially available spreaders. Well, can anybody spot my deliberate mistake here? So I've detensioned the spring. I've wound this back in all the way I can. But of course the spring is preloaded, so it's still completely jammed up against this, you see? Because the spring needs to come in a bit more before this will release and come out. So So if you take that information, you could build something like this, hang on, which is a wooden kind of model that you use to form your aluminium body panels around. I'm using a cheap, like this is the cheapest laser cutter money can buy. It's called a K40, it's Chinese. There it is. And so if you connect that to your laser cutter and start cutting, it will cut out that pattern, and bingo, you end up with something like this shape, see here. And then you can build scale models. And I also can produce a kind of negative one to see if I would fit with an engine. And this I am to scale, and so is the engine. Each of these blue squares represents where the camera was, how it's facing when it took the picture, and you can see in the middle of all this blur is a rendering of me sat, so there we are, sat on the floor. I don't know if you can see that. So it will, I don't know, it's a bit like a CT scanner or something like that. It basically crunches away for about 4 hours processing all these photos and working out the directions they're taken from, and it'll produce a three-dimensional image, and you can export that to a 3D printing program which would then run on your 3D printer. And so doing it with a bit of maths, just pocket calculator stuff, I can print a model there of me. So if I put in a perimeter frame, a ladder frame that's 100mm deep, the top of the frame is level with the join between the upper and lower panels. What I can also do is work out how far in the edge of the frame needs to be so that the bottom of the frame isn't hitting the curve of the underside panel, and then we can take that to a point where I can draw in where my frame rails are going to go, where they're going to be bent. If I do pie cuts, I can work out what angle they need to be. I can even go online, and there's things called triangle calculators. So if you make a pie cut, it'll tell you, if you imagine it as a narrow triangle, how wide a pie cut needs to be at the inner edge. So you're going to cut a little triangle out. So here it would need to be 9mm across, assuming my box section is 50mm this way. So 8.3, 6.9, 9.89. So if I cut my pie cuts to about that and then bend the box section prior to welding it, the edges should meet up and it should be exactly the right angle. So there's far more planning in this than any of my previous projects, to be honest. So what do we end up with? Well, I need to cut a full-size template for use in the garage.
Look, this is the amount of land we've recaptured since yesterday.
Oh, excellent.
What is the actual scale of this map, darling?
1-to-1, sir.
Come again?
The map is actually life-size, sir. It's superbly detailed. Look, there's a little worm.
Here's the front on this big piece of code. This is 1-to-1 scale. We come right round. This is just one side of the body because I need to work out how to cut my chassis rails, and then it comes down to the bottom. Measured that out on my steel bar. So, like, where are we? Here's one pie cut. So I've just laid this out on my pattern, and if we start with this one here, I've just tack welded a bar from there across to there, just using a cheap MIG welder, just to hold it exactly at the right angle while I TIG weld it together. Well, this second one is faster because I can use the first one as a template. So you can see I've just got some tack welds. Right, I laid these two halves out on my full-sized cardboard template and got everything perfectly lined up, and then I put these little screws in to my homemade platform here with little markings, and same the other side to hold it exactly in the right place. And then I G-clamped these two cross members on, and I've just used the MIG welder to zap away, fix them on. Eventually these will be cut off. These hold the sides in exactly the correct position, so they're not going to go anywhere while I build everything up. So the next thing to think about is the front suspension. Right, so we've cut out my circle. So that's how the body, that's the diameter of the body at this point. So what's this telling me? Well, I know the top of my bracket is going to be ideally 14 centimeters above this tube. Head round it really. So here's the ends of my box section here and here. You can have vertical bracket, whole thing tipped back 5 degrees. Spring will be something like that. It'll sit inside this channel here, which is U-shaped, and then you'll have the big U-bolts here and a plate here clamping the whole thing up there, like that. I'm filming this about 4 hours later than the last clip, so you can see this is in. These are welded in, all the welded up on the inside. I've just got these to finish off on the outside, and then I've plated down here, and I've plated here. I can't use the standard plate because the width there is now greater than the spring by about 10 mil. This is 5 mil thick steel. So I found the correct size. They're actually a Land Rover part. I think they're Land Rover or Range Rover, but I mean the thread's way too long. I'll need to cut the thread down, but actually they fit bang on actually. Side. Okay, but that should have fit. I just need to round off these edges and make it look nice. Here it is all bolted in. You've got to make a hole in the middle of the plate as well, because of course there's a nut on the end of that thin bolt that runs through there. I've got one of these little magnetic gauges here. The lean back of my kingpins here, the back lean is 5 degrees, which is what I calculated it should be, which is always a good sign. These are parallel to the ground in this position, which is kind of what you'd expect them to be, and also my rod ends here will go into a bracket on the frame, but you can see I can actually tuck it under the frame just a little bit like that, and you might say, well, what difference does that make? It just helps a little bit with the turning circle, because with this particular type of axle, I think in an earlier video I talked about them, you can get different axles, different widths, but also the widths between the spring perches are different. So it's this distance here that's important in terms of whether the wheel hits this. So it affects your turning circle. I think that's going to work. So here I've just mocked up the suspensions. This is the early Porsche 911 or 912 steering rack. So this telescopes in and out here. Here's the adapter I had made. Renault Megane inner track rods, 95 Ford Mustang track rod ends. I just got this off eBay because they're really cheap, and they're compact. It's a Volkswagen Polo from about 2000 and I don't know, 3 or 4 or something. Steering rack. They're really low priced on eBay, I assume, because there's more of them than people that need them. But you've got a big universal joint here. And look at this, it's telescopic, so you can make it fit your car easily. We've got a functional steering system. Well, I've got bad news and good news. The bad news is I thought I'd just check with the Vintage Hot Rod Association whether it will be alright to have a small narrow steering rack tucked in under there, not sticking out past the body, because most of the car has to be in the spirit of the way cars were built at the time, and their answer was no, you can't have a steering rack.
£1,500. Computer says no.
It was nothing to do with the possibility of a bump steer, which is where when this wheel goes up over a bump, that track rod will move up an angle, and so it will pull it in slightly. So what was the good news? That was the bad news. The good news is, do you remember I made a cross section here? This is a cross section here. This is an adapter from the end of the gearbox to the input of the differential, and if you're putting it on a lathe, I worked out that's the kind of cross section. This hasn't been printed to scale. That's actual size. That's kind of a cross section of what you need to make in a lathe. So look at this. There we are. Made for me by a local engineering company. I thought it was going to be aluminium, but actually it turns out it's in steel. But the price was right, so I'm not complaining. See there, and then this end will go there, on the end of the gearbox, and there should be enough room inside for this universal joint to go around without smashing into everything, if I've measured everything correctly. Well, believe it or not, there is a serious point to this. This is me. Well, I basically sat down on the floor and drew around myself in a driving position because I want to know how much of my head is going to stick out of the top of the bodywork and where to put the seat and where to put the firewall behind the seat and the tubing of the rear of the roll cage. I now can work out how high my head will be above the chassis rails, and from the cross-sectional diagrams I've got, which I'm going to cut out in plywood as well, cross-sectional rings at each of these marker points which correspond with the points in this diagram. I can then work out what the roll cage needs to look like, how it's going to be welded at points onto here, how tall it's got to be, and from that how big a fairing I need to go on top of the belly tank. So if I draw a line down there and then move it around 35, I should be able to get that angle worked out. Well, don't laugh, but here's me, right? This is the first hoop, comes up, you can see the wall of this is the wall of the aluminium body, the belly tank. So as much as possible it comes up inside the wall, then pops through and then comes up around my helmet. The steering and things will be mounted to that. It kind of springs back to a certain degree. Right, so yeah. Just taken from some 5mm thick box section, and then I'm going to put this piece here, which I'm shaping to exactly fit, so that when you remove the back end, the idea is that the frame rails will just slot straight back in, the bolt holes will just line up, and it won't distort or change. In other words, it just push it in, bolt it on. So you see the whole back axle comes off now, quite neatly. It's held on with 8 bolts. Good news, my roll cage tubing has arrived. The only other thing I want to do is check where it fits. I've spent ages getting that right. So these are the loops that will go underneath and hold the floor, and you can see from the curvature of this that it will just skim it and miss it. Upside down at the moment. So these will form the floor of the driving compartment. Some of these come in the mail, and I think it's a Ford Anglia steering box, so let's have a look at that. Right, well, the first thing about this is, yes, it turns, okay, and that moves, because of course the worry when you buy a steering box like this, this kind of unknown is it completely knackered and worn out, and there's like massive amount of steering wheel movement before it actually engages and moves. This is a new old stock tie rod end from Ford Popular, and you can see it does seem to fit pretty well. Well, this actually worked pretty well, apart from the mess with the cutting fluid. Yeah, you put your electric drill here, you keep the speed down, you keep the plenty cutting fluid on it, and it will cut you a notch. Yeah. what I'm doing here is attempting to straighten out one of these trailing arm things which is slightly bent. Yeah, it's getting there. Right, I've got to wait for some longer bolts to come to go through these two holes from the inside into that steering arm, but in the meantime I need to think about my the rod that will go from here right the way across to here. And I already have these ball joints, which are the 95 Mustang ones from my failed Porsche rack idea. This is an M14 by 1.5 right hand thread in both of them. And I have these, which are the René Megane track rod ends, which screw into there. And you can see this part here is cylindrical. So I thought I'd cut it here and use these and buy some tube, thick walled, like 3mm thick, precision tube, and slot this in, and then weld it around the end and plug weld it through at several points, and then I'll have a rod that's adjustable that I can run across here. With all that down, you can plug weld it then into the end of a piece of 3mm wall tube and start constructing suspension parts around these. And these are the Mustang 1995 Mustang, which have the forward fitting on the outside end, and then they have the M14 metric, M14 by 1.5 female thread up there, there and there. Okay, so shine everything up. So the plan is take that in there. Right, plug weld, plug weld, plug weld, weld around there, same the other side. Then steering column, put that on there, same thing, get the general idea. Here it is all finished and put back together, so you can hardly see the plug welds, and I've welded around the ends here as well. This is all in now, bolted in. And I'm actually very tempted to put a bracing strut across from here to here. There's a set of drop handlebars for a racing bike. Now these are quite old. It was just luck I got these. They're made of steel, most of them are aluminium now. And also if you look at that part of it, it's a tight bend. In a bit more than that. Basically they've got to, not like that, they lean in slightly. If you look at this one, which might be a P38, but I'm not 100% sure, doesn't lean in quite as much as this one. Well, that's not too bad. Now I'm cutting a ring off here, which will go here. Not too bad, even though I say so myself. That's the back there. I've made some hand grips each side. So these were done in left and right halves, sorry, front and rear halves, and then glued together. So obviously you've got to have a cutout for this. Again, they were done on my 3D printer. So that's what they look like with the buttons in. So another one, World War II, doesn't say which plane, but again, interesting to see how it's made. £2,285 for the one seat. So it looks like I'm going to have to go on eBay. People do make reproductions for rat rods. Here's a pair, powder coated, 480 for a pair. So 200 and something pounds each, made of aluminium welded. So I may notch this where this tube is and get the seat
instead of resting on the tube, the base of the seat will be more or less level with this side of these tubes. And also I'll tip the seat back at more of an angle like that. So with lots of alteration, I think I can gain another 2 or 3 centimeters, which doesn't sound like anything, but actually it makes a difference. Well, I've learned my lesson this time, and the lesson is turn it over, try it out before you start welding in tabs to hold the seat properly. That's good. Right, this is how you get out. Right, that's the view. Pounds in an imperial ton, 2,240. This has got 10 splines and this has 6. If you can see that there. So it was my kind of understanding when I was doing my homework that the spline pattern here was the same as this one and they would slide together. But I'm obviously going to have to do some more research. Per minute. So what's that come to? Times 90.39. Right, there, 89.898 inches per minute. Oh, miles per hour, don't we? Right, so we know. So we 60, we get inches per hour, and put that to miles. So I'm probably going to end up buying one of these. I've got a book on essentially how to rebuild one of these. So I'm going to have to go through that. Speedway Motors also give you an instruction manual on how to fit it. And there's also some YouTube videos, like this guy, Wired Customs. He's got a video on how to reassemble one of these. I've had more trouble getting drain plugs out of cars 40 years younger than this one. Anyway, this bit goes in there. See, that fits pretty well behind that. So it's also like an adapter insert which goes in here. Right. That someone's made to make this work. So I'm just greasing this up and I need to get this thread all the way out. This side was a real pain. I did it up really tight. It still didn't budge. So if you look at the end here, clearly people have been hitting it. I went on some of the forums and some people say you basically hit it once with a sledgehammer and then you tighten it again as tight as you can, hit it with a sledgehammer, tighten it again. Other people say just leave it overnight, sometimes it'll pop off by the morning. Keep retightening, leave it overnight, keep retightening, you know, just be patient. And then of course the other idea people have suggested is heat it. So I've just got this cheap propane torch. It's really old and rusty, still works. Just heat this area here, and sure enough I've just heated it up. Just got it to the point where the paint was starting to burn off a bit and it's just popped. This is the difference between YouTube videos and reality, although this is a YouTube video. I've managed to loosen most of these using the 9/16 spanner. On this side, where they've been taken off more than once in the past or something, they all seem a bit smaller and I'm just rounding them off. So the only solution I've found to that is to hammer on, and I mean hammer on, a 13mm socket, which is a tiny bit smaller, and hit it and it turns. And then to get it off I use this beat up old screwdriver, but it's metal all the way through to the end. I put it on like that, hit it like crazy, and then the spanner will fly off. Oh yeah, here it goes. Whatever it is, it's moving. Ah, there we are. Just need a gentle persuasion. Oh. Look, that bearing looks pretty good. crown wheel's the other side of the pinion, so I need to take that side off and slide it all out that way, which would then leave us with the banjo. Fair enough. That works. How about that? Interesting's come. So let's see what I've got. Oh dear. Really saying it won't go in? Panic over. I was really worried then. I thought I'd missed something else. Right, it does go in. We've got 39 teeth here, which is 3 3/12. So you divide one by the other. Basically, it is 3.25 to 1, which is what I ordered, but it's worth checking. So I'm just waiting for the threaded rod, 20mm diameter, to arrive to make my bearing pusher outer, pinion bearing pusher outer tool. It's this. Goes here, pushes out this bearing. You see there's a little dimple there. Work. So it's a great big threaded rod with a big nut on it, thrust bearing, a few chunky washers, and this thing fits over the top. We've got a tube with a washer welded on it, blob welded in the end, blobber weld on the end, which should fit into that dimple there, you see, and do the job. That looks like it might work. Managed to slide a bit of cardboard in behind there as well. So, but before I do that, I need to take this lot apart. So I need to knock the tabs, bend the tabs the right way, and undo this. I might need to make myself a special spanner. It work. So let's see what happens. I'm just letting it cool down first. Just looking at this, I'm not sure what's going on here. There's like teeth marks on it. Maybe they've held it in some grips. And then I'm looking at these deep gouges. I'm going to gently push that way, and this nut should just come undone, shouldn't it? Well, the spanner nearly popped off, but just before it popped off, it did start to turn. Look, it's starting to go. Ooh. Interestingly, it doesn't get any looser. It's still quite hard to turn. Something popped off then. I think it was the tab of a I'm going to heat the case. It says you should heat the case with a blowtorch. Just warm it up to expand it, and then turn this nut, and then this stops the tube part rotating while I turn the nut up against the bearing here, and it should push it out. Again, what could possibly go wrong? Quite a lot, actually. If anything, that was the tighter of the two. That suddenly popped and then came out. Yeah, so we've got to think about that much more to go before the next big bearing comes out. I'm using the blowtorch just to heat around here. Apparently you don't have to get it incredibly hot, just sort of, well, I'm not going to try with my finger, but apparently so you can just sort of, just pretty hot to touch it. You wouldn't put your finger on it, just sort of a bit less than boiling point maybe. I knew that was going to happen. Right. Nothing looks too damaged. Mary Celeste in here. Where's everybody? Nobody here. Old school. Old school. Look at that. Isn't that great? Ah, here it is. So what's he done? He's made me a bush. Yeah, he's made me a bush, which exactly fits that. See, exactly on the steering shaft. Right, I've got this Penrite stuff. It's like, it's very thin grease, or it's very thick oil, and I've got a 50mm syringe. I used to work in a hospital once upon a time, and it's thin enough to go into the syringe with a bit of. Right, now that means I can fill this up from the base. Just fill away. Whee. I think this will be the best lubricated it's been for the last 40 or 50 years. It's all back in, put together. These are temporary bolts, so I'll get some proper high tensile ones with lock nuts of some sort later. So the true test is how much play have we got now? Well, if you look at the steering arm, it's just starting to move there, and then it's just starting to move there. So the amount of play is about from there to there. See? No, this one's a bit loose. See what? Oh, okay. So you have to take it that way and then these screw together, until we feel like I can play with it together. Let's get these together. In the middle, you can stretch yourself, tap it with brass, twist, tie brass, brass, so tap it all around, and then I like to that way, so it goes down. Nice, just down, tap it back, fairly hard, around the edge, get the movement doing. It's off, it's in this one, this one, no, so these get like you really tap them off, that's all I'm going to get in the middle of the wall, that's what I'm losing it. Check, double check, right. Oh yeah, it's going. Look at that. I'm not using a huge amount of pressure. We've got that on film. Oh God, there goes. Get a bit tighter. I'll just get rid of some of that. Okay, keep going before it gets. Using yours up, just a bit, just that way. Right, put it back together. Get the pressure now. Oh, there it goes. Pretty easy. So I'm just going to make sure this spins freely. I don't want to take it to the point that it's tight. And then there's a few nuts. Come on, so we're going to need to check it off. We're going to take all the first, no way. Just testing up what's going. The budget is tested up to find us such that we're just doing this about 15 pounds, didn't look up, £12 £8. So now obviously, but we knew these order, that's the big capital, just £2,000, some set off, then we use that. Let's go there, and remember, and it's in order, so it's going to be let's put some loose off. Okay, anyway, cost this. Right, anyway, yeah, it's Yay! Right, see? One pen. It's half in the vise. Right, as you can see, it's starting to, something's starting to happen. Ooh! Ah! Ah! Well, look at that. What do we got? What do we got? Ah! Do you know what that is? That's the locking tab washer for which goes. Oh, it's in the other room, but goes sort of about there between the two nuts which are locked together. Out it comes, as I knew it would. There we are. Dun, dun, dun. We'll reconvene in about an hour. There we are. Crown wheel cam. Dum, 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 dum. This will get covered in condensation now. You can see the ice forming on it. So I'll put it on this wood. I'm using a glove, trying not to warm it up with my body heat. Right, now we'll go and get the warmed up bearing. There we are. Oh no, it had got to go a little bit further, look, nice. Right, the crown wheel's on, nuts are all done up, bolts are through, it's well seated. So the next thing I've got to do is check what the torque settings on these should be. So here's the bearing race each side, and here are the tapered roller bearings, and these are the axle housings that bolt on. You can see the ring of bolts there to the centre section. Now there's a gasket here and a gasket here, but those gaskets aren't just gaskets. When you buy them you get a pack, and there's several gaskets in there of different thicknesses. They also function as shims. So why do you need shims? Well, if you think about it, if you're going around a tight bend, the axle is going to be pushed to one side or the other. So if it's being pushed that way, you want the force to be taken on that bearing, and if it's being pushed that way, going around a corner the other way, you'd want the force to be taken on that bearing. Now if you look at this way, suppose that you're going around a corner and the wheels and axles are being pushed that way. What you don't want is that bearing to be loose. So all the force, the sideways force, actually gets slammed into the crown wheel and the pinion, so it gets forced onto this pinion. Now if you're just pootling about and not cornering very fast, it's so well made, it would probably take that for a while without too much trouble. But really you want to have no play that way before you even start thinking about the crown wheel and pinion play. So there's different ways of doing this that have been described, but the main things are, first of all, you've got to get the side-to-side play here just taken out, and the way you do that is with the shims. You put different gaskets in until it's just, there's no lateral movement, and you can just spin the crown wheel by putting your hand in here and flicking it with your finger, or grabbing the ends of the axles and turning them the same way. There should be slight drag but no lateral movement. So once you've done that, this is what I've been advised to do as well, you remember what shims you've got here and here, and you add them together, and just make a note of that, because then later on you're going to be looking at the free play between the pinion gear and the crown wheel, and that's measured by, once you fit the crown wheel, which is your next step, sorry, your pinion assembly, you rotate it back and forth and use a dial gauge here, which I do have, and there shouldn't be more than a certain amount of play. There should be a tiny bit of free play, but not much, and they certainly shouldn't be binding. If they're binding, what you would do is you would put a thicker gasket there and a thinner one by the same amount that you thicken that one, you subtract from that one, which would move the whole lot that way just a tad. It would keep the distance between the bearing races here the same, but you'd have moved the whole lot that way tiny bit, and then it wouldn't bind anymore. So they're the principles of how you adjust this, and I've actually used a mixture of what's recommended in both these books plus comments underneath some of the YouTube videos that I've watched. Try again. Just be careful not to smash my ceiling lights. Right, that's better. So the plan now is put another gasket on. I mean, we don't know what size you've got to use, so just pick one, do it up and see if this binds. If it binds, we put a thinner gasket in and keep going from there. And, I would rather put this on the axle housing actually, but crown wheel and turning my fingers. So it's what they said, which is there should be a light drag, there should be no play, and you should be able to turn the axle here with your hand, and I can do that quite easily. It's greased. So we get on. And it's flush with the surface here now. Basically I've 3D printed it, because basically 15-inch pounds is not much torque at all, and a 3D print might be able to withstand that, I suspect. It looks like I'm going to have to print another one slightly larger, but you get the idea. Right, so you can see that the print, it's not pretty, the print is on. Storage is in, 15-inch pounds is like there. So if I hold this, I'm going to put 15 pounds without the 3D printing, and the answer is, well, that's 20 there. So you can, ooh, he's not happy, it's on the border. Alright, I need to do a bit more. Ooh, God, right. There we go. Cheap effects hole, hole, do a hole for the prop shaft. Home I can see the same way it's working. So I'm going to go to the winding. And then I'll put the storage jump and get 15 pounds just there. So the moment I'm going to go. Okay, I've printed this out. Remember the other one, so this is now printed 100% it's solid. Here's my inch pound storage. So it just goes in there. Now, I need to measure the pounds it turns all that chapters. So we've got 20 too much. What it's turning is 10. And to break the kind of seal, it starts at 20. It's 10 around. Just let it go. It's more like 20. Actually, I think I'm happy with that. I mean, it's 15, so it's about now. You get this. Well, you need a bit more check. There. Enough. Okay, so something enough. You do the one watch, so let's go that. And the looking around, you can check the wood. 20 again. There, wood, and the watches. Right. Put this one back. That's it. So that way. So what's next? I need to go nuts on the crown wheel and the lock wheel. I have lock wires. That's like bottom of the banjo that way. So let's do right, hear the click there. And eventually it comes out of here, back in there. It's probably all clogged with paint and God knows what anyway. It's probably easier to just do it like that, to be honest. So I've packed those with grease. I've put the key in here, so we'll see if I can slide it on now. Obviously I've got to line up the keyway. I've marked here where the groove is for the key, just so it's easier to slide the whole thing on. Okay, so there it is, done up reasonably tight. So the only thing left now is to put the wheels back on so I can actually roll it around the workshop a bit. In fact, if you can see, it just slid straight in, to be honest. There was obviously just some little burr or something there that was stopping it. So that's fine. What I am going to do is push it in all the way till it won't go any further, and then just measure the distance between here and here to make sure, hopefully, that this is just a few mil longer. Right, well, hopefully you can see this. There. So that will clear the pulley. It will clear. Gives enough room to push the hoses on each side. Okay, so you can see here I've got the highest quality bolts I can get into the similar quality captive nuts on both sides. This side I've done the keep it simple stupid method. I don't know if you can see there. This is just 5mm thick box section. I've only tacked it in. And the rear engine mounts just rest and bolt through. Kind of part of the plan is if I was in a head-on collision, even if the bolts broke or weren't in, it still can't actually move that way. It's got to kind of break free here. The only way this engine goes in is by dropping it down. As you can see, I've not been doing nothing to it. If you remember the last episode, I had the engine mounted. I've got my engine mounts in the right place, so I've taken the engine out and I've put my muck-up bodywork sections at 1 foot intervals slotted onto the chassis. And then
So I'll do this side now as well. Again, it's 1950 springs. You notice there's a kind of way around it. This loops over here, so we've got a roll on this. Loops around here, we've got on there. I might have to turn the springs. First, that goes on there. Like that. Then these are gone. I changed time. These springs need pulling really hard to get them to the here. So I'm actually going to fit this too hard to the axle. Otherwise I'm going to take the bench, scratch it. So we're going to need more solid temperature when we tension on that spring to get over here. So I'm going to bolt this on now. I remember from the previous designs that were this thing fits here. And you can't use any gunge or leaky oil or anything else in that little tray at the bottom. Stops it dripping onto the drum and then it so I want to keep it. And we do top of it. Fouls the cylinder.
And then also I'm going to glue little blocks sticking out on all of these level with this top edge, because that's where the perimeter of the upper half of the shell will line up with. I've just been to the DIY store and got some timber and some 8-foot long strips of steel, and I'm going to use these, I think, to help form the shape lengthways, because you can bend them to shape but they're rigid enough to stay put once you've done that. There's the weld. I welded 2 more down here for the sides. So now the thing is to put the curve into it, including a little slight negative curve here, and cut the slots and then drill holes, and I'll screw it down into the wood. Well, although this is a bit time consuming and fiddly, I think this is probably a good idea. That's come out pretty well. So that gives me an edge to work to. So basically the bottom edge of this rail is where the seam will be all the way around. Well, it's happened, everyone. I'm officially a member. Look, and there's my membership card.
So just take it so easy, and let's check. I will this one, so I'll leave it with you. But I'll leave it back here. Just rubbish on this, and I'm not sure what it does. As well. And also got all these belt fixing sanders, so we'll see which you want to this way. So which one is to see this is I'm going to make on this. So first of all, I'm going to use the flat disc. We'll checking like this with your letters. There we go. Okay, nice. Not too bad. Yeah, you can see the polishing. I'll just try the device just to treat. Which you find out what it makes. How you spin it, just rub it. Well,
Right, now, so test fit. You can see now that this edge was straight, but now it curves a bit in because of the changing shape of the panel. So if I look at this edge, you can see, I mean, it needs bending a bit that way, but you can prove the pudding. What about this end? Because this circle is smaller. Well, look at that. If I just give that a little nudge, you can see pretty darn close, isn't it? I've seam welded this. It's extremely difficult to get the edges not only perfectly lined up, but also perfectly lined up in height. So like you weld here and then there's a dimple here, one slightly higher than the other. Improved it a lot here. This needs grinding down a little bit more. So I've made a whole load of these, and you see they're quite simple. You'll slide them out as far as you need to until they touch there, weld them to the frame, and then you see that bit will stick down there and form an attachment point for the panel coming up from underneath, because the top panel lower edge 2, 3, 4, 5, 6, 7, 8, 9 ready to go, and then I need one here, but it needs to step up and then come across, so we'll work that out last. I've got the other side to do. I'll go right to the edge with this because I'm not shaping the panel, I'm just trying to bend it in one way. I'm going to have to remove my camera because I need to come right up. Blended it in a bit better so it's not low anymore. Bit of a bump there now. That's come out really well actually, considering there was some uneven lumps here. I've been wheeling it, just this end, because this bit won't fit into the English wheel anymore, but it doesn't matter because there'll be an engine cut out there for the cover. But this part, I've wheeled it under light pressure so it just gets stuck where the bumps are and smooths them down. These guys weld panels together, you see, in a rough shape of a sphere, and then look, they inflate them using high pressure water, and they have it sort of resting in a dent in a bed of sand. This is something on a smaller scale. You can see it's just been seam welded and it's been inflated with a pressure washer. I think this is steel, not aluminium. You can see water starting to squirt out of small leaks, but you see it more or less forms a sphere. A lot easier in cardboard than it is in metal, that's all I can say. We've got improving welds. You see this bit here, it's not too bad. I brushed everything, so I'm going to tack each side and then weld round. Right, I've got this cobbled together. Just do it first. Ooh, bit more. Stop. Just right forward. 1, 2, 3. Ooh, something popped. Well, it's changed shape. Get the curve right, so I can make a template which I can put over this, and then I can keep working it until it's the correct shape. And it needs a bit more finishing, but you can see how roughly it will fit there. I've also made another top panel ready to go on the underside, because eventually this car is going to be completely flipped over, and I'll do the underside first and then I'll put the top on. I've extended this bulkhead round. Eventually this will be cut off flat to match this, but just for now. And then I very carefully, with a lot of measuring cardboard templates, cut that out. I will grind these down, but not yet. So you can see when we flat bottomise this, as it were, it's going to cut around sort of to here, and the flat panel will be welded on. Come along here. The nose panel is here. I've welded this piece on. My welding is getting better. Just working on getting these absolutely perfect, and these are too small at the moment. I'm just chipping away at them till they're the right size, and then I'll get them to match each side. Now I know this isn't, W40 is not cutting fluid, but it's kind of good enough for this. Next bolt. Right, so I've trimmed this back roughly. This gives about that much ground clearance now when I flip the car the other way over. If I go from corner to corner with the top of the tyre, you can see just misses. It's the same the other way. You can see I've trimmed it off using cutting wheel in the angle grinder. So now I need to make cardboard templates for the aluminium, which will be welded on. In fact, the most aerodynamic shape is to keep the full teardrop shape and have the ride height set quite high so I can actually go under it. So in fact, this is not the most aerodynamic shape, but it's probably the coolest looking shape. So I'm going to weld in this strengthening bar because this one across the top here is just temporary. These arms, and one side you can see is wider than the other. The back side's been welded, looks like machine welded to me, and the front isn't. In terms of rust, just be a bit worried that water might get in through this crack and kind of rust it out from the inside, so I may put my own weld around there, and it's as close to the top as I can get it while still being able to turn this, so that's good. Okay, so this is the problem I've got here. I've got this nice forge piece which will bolt on here, but you can see these are designed to meet in the middle of the original car. They bolt to the torque tube, so what are my options? I can shorten this to about here and have a bracket here to take it. So I've just wrapped this in cardboard and used these quick release cable ties. Just locate it and so it holds it in the right place while I just get this right. Now I could put it like that, but then the hole in the bodywork is going to be a big oval sort of here. Now if I bring it out a bit like that, you can see the body's going to come around here like that. So I need the body to ideally just miss the top of there. Right, so I've tacked that end. I had it resting on this block, on this seat, to get it exactly right. So now I can unbolt it there, and then unbolt it there, and then weld it properly. There we are, so it all bolts up neatly. Right, I sent this design as a CAD file to a local company to laser cut it in 3mm thick steel, and you can see it looks about right. There is a deliberate mistake, you'll see, in that I've got 2 bulkheads. So I don't know if that's good or bad. I've got a spare bulkhead basically. Yes. 1 bulkhead. Oh, this is Tatra. Tatras were famous for having a rear V8 like a VW Beetle, air cooled. Now look at the exhaust. This is one side of the V8. Here's your manifold, but look how the exhaust tips, they're folded down into a sort of U shape, and there's 4 of them, and look at that, they form like a circle. And you think, why did they do that? Well, actually, on the road cars there was a fan here that was driven by a belt from the prop shaft, one each side. But you look, on these cars, these are race cars, so it doesn't matter if they're loud, the exhaust tips are narrowed, so this air comes out at faster velocity, if you like, into a larger outer tube. There's a better view of it. Now what was that doing? Well, it's called an extractor exhaust, sorry, an ejector exhaust I think it's called. It fires out into a larger diameter pipe, and remember this outer pipe, this is where the cooling air would be drawn over go in the top of the engine, over the fins and out here, and there'd be a big fan here and a big fan here. They got rid of the fans, reshaped the exhaust and put it into this wider, getting wider and wider, sort of cone shaped exhaust. Basically they fitted out an aircraft and compared different types of exhausts. So you can see here, instead of all these exhausts from all these cylinders going into a great big ring pipe round here and a normal exhaust, they all come out as little nozzles into the outer cowl, which sort of helps draw air through. I then found this. It's on YouTube. It's some guys in Russia who have kind of got this old missile carrier truck running, and it has an engine in the back, and it's got a radiator that's flat just in front of the engine under this hatch, and air goes, so this is a bit of a rubbish photo, air goes down to this grill, the radiator's under there, through an ejector exhaust out the back. But the ejector, the kind of cone shape, the widening venturi part, is aluminium, and you lift that up so you can work on the engine, which is under here. So if you look into the engine bay of this thing, so it's the back, looking at it from the back, here's your engine. That thing's been folded up. These are the tips of the exhaust from the engine. My air's coming out into my engine bay, so I've got to have holes to get the air out. As I say, I can leave the tail open. I can have a small fairing which goes just under the diff, I've seen, and that could actually be open at the bottom and no one would see that, and my airflow would come out here. Or I could make some kind of extractor exhaust, but the exhaust would be coming down here, and then my wide tube here, and then it would sort of have to stick out the side, sort of faired in with this quite big, it almost like a jet pipe exit. The next thing is to put the body front and rear panels on and work out where my fastener holes are going to be. These clips are a success. You can see they work. I was going to put foam rubber between here and here, but actually the clips pull it really tight. Then I got a felt pen and I poked it through the hole of these mounting points onto the inside, took the panel off, drilled the hole, and you can see I've actually drilled the hole in the right place, and it's quite neat, isn't it? Welded in. These are the holes for the lap straps. So if we imagine they come in back at an angle like that, then put a plate here, plate here. I haven't actually welded that little hole there. I thought it might be useful as a drain hole, otherwise stuff would just collect there. Right, I've just etch primered the underside and I'll paint it black. Just the awkward areas to get once it's the right way up. should just test itself. There we are. Now, right here I'm just doing some final test fitting, and if I measure correctly, the wheels is just going to slam onto there. Not sure if it's going to bounce off and then these tyres boing all different ways, and then it come to rest again, but even if it did that, it kind of breaks the impact slightly. These tyres are pretty soft. Not bad. So that's the nose bolted on, so you can see there's no gaps there, more than a millimetre or two, both sides. It's touching the wood, except for here. So I don't leave any lines. Try not to leave any. You can see all I've done here is wheel it back and forth. The other way up, this is the underside. Not quite reaching the edges. See? And you can see now, as well as curving that way, it's also starting to curve that way. See? And it has less marks in the metal. But you can see that going to need trimming back. So the next thing now is I can see where I need to cut these now, which is good. So I can start very carefully trimming a little bit at a time. Okay, so I've trimmed that. I haven't trimmed the bottom edge yet. Need to trim this back. See, that overlaps there. But it's always best, it's always easier to trim stuff back than add metal, so I'm actually going to make the screen. There'll probably be some side bits here and then a piece that tapers down like that around here. Should be able to work this in and the splines in as well. There it goes, you see. Right, now I'm going to stop there before I ruin the gasket. So this is my buck basically to make that, and then so it's all just tack welded together and screwed, and then I'm still going to have structures that go like that down the sides, but they're actually going to be air scoops. Not sure if they'll be louvered or scoops, feeding kind of in to the bottom part of this spine, so they're going to run like that, and they'll be separately made, tapering down to nothing. So it needs to come about 1.5 centimetres, or 1 centimetre each end, maybe something like that. Right, so I'm pretty pleased with that. It's a good fit here. Most importantly, it's a really good fit here onto the wire under there. So the next thing is to mock up this piece. So here's my cardboard template. I'll ease it into shape and then polish it. It may actually be almost invisible then. Not too bad. Reasonably pleased with that. So the cunning plan is to have a set of these. 1, 2, 3, 4, maybe 5, getting smaller. Right, first of all, my tabs are bent enough, because if they weren't, it would push the lower edge up. And I'm trying to get this tip to start about there. Right. Talk about the gear change mechanism. Now basically I've got a gearbox at the rear of the car with a gear shift sticking straight up and a an engine in front of it and then me sitting at the front. So how are we going to come up with the gear change mechanism? Now this looks rather kind of cobbled together, but it's quite clever. You see that this rod slides through this sort of bushing, and then this whole assembly here pivots like that forward back on a bearing point here and here. So as you see, this has got a pivot here. As you push this rod back and forth, this whole assembly tips back and forth, and there's an elongated hole there, so that moves the gear stick back and forth. How do you go left right? Well, if you've got a kind of pistol grip gear shift fixed to the front end of this rod, you can rotate it, so the rod, you see, can also rotate like that, and in fact there's an arm sticking down there which then pivots like that. You can see it here, and then you've got this weird shaped rod coming up here, and that's why this hole is sort of oval. So we've got the tyres, we've got Goodyear heavy duty inner tubes. What I forgot to order was like the rim tape. It's more for spoked wheels, but actually these wheels, they have rivet heads, they're just domed around the inside. So the guys at the tyre place recommended I did actually use rim tape, so I ordered some rim tape, which is like a wide elastic band, about that wide, and it just goes around this part on the inside before you put the inner tube in. The next problem was the inner tubes, these Goodyear inner tubes, I don't know if they come in different types, but the stems are narrow, but if you notice the holes are wider, they're almost half an inch. But you can get collars, these plastic collars. They're not necessarily recommended for sort of you know, long distance road use, that kind of thing, but then on the other hand, these wheels are going to do what, 20 miles in the next 20 years or something ridiculously small. So, let's have a look. Now I've actually measured this. At the rear here it's about 8 millimeters higher than it is at the front, so I think within the limits of error that's pretty good. Well, I've been doing a bit more welding, so you've got this bracket now which holds this, so that's an adjust, the cable goes through there and you can adjust it, the length. So the cable's coming from the front of the car, and then you can see I've welded on an upper and a lower thin piece here, and the reason I've got that drill bit in there is because this will go, so that will go in there, and then the wire goes through that little hole, and the wire comes out here and goes into there. So I've got a reasonable amount of travel, and then the pedal is there, so I don't need to shorten it at all. I could put my heel here, angle my foot out a touch and press that just fine, and then the cunning bit, the shaft goes across to here where we've got pillow block bearing, if you can see that. Right, these have just arrived. This is an extension piece to go on there. Go to there with various lock nuts. So I'm hoping that will do the check for that. And then I've checked that the cylinder is level to the ground, which it is, and it's level to this rod, which it is pretty close. I'll just do a few final measurements, and then probably I will tack weld these brackets on. And if I operate the accelerator, you can see it moves. I've measured it, it's about 40 millimeters. How that fits there. So you slot that through, then there's a side cut in there that you put the cable through, and then you slide all this back down. And if I move the pedal, you can see it's all in reasonably good straight line. And then it comes in here. So let's get the light right, as you can see. Okay, so that's fairly straight. That's full treble and back. So that's pretty good. Looking how the handbrake mechanism works, and you can see it's pretty simple, like that. So I'm going to put this on the next to my right hand. So really I want this to stick up that way and push back onto a master cylinder. You can see I've tack welded it there and there. And this rod is in line that way. It's angled slightly down because as this comes round, as this lever comes round, it comes up a bit. So it gets from there to there, it comes up about 1 centimetre. So I've deliberately mounted this level, but with the rod just a touch angled down, so when it's been actuated it's actually perfectly level. The problem here, even with the quick release, which will bring this further out, you can see my legs, it's all a bit tight. So if the steering yoke was about there, that wouldn't be so bad, would it? Should be that way around. Yeah. So there, that's the quick release. And that fits over the top, so it slims it down quite a lot. The ring has to pop out, so let's just see if it does. Yeah, you see how it popped out? So if I can turn these down and blend them in here with these, then it shouldn't look too bad. So you can see what I did there. I said to myself, I got to cut there, don't cut there, got to be there, don't cut there, and then I cut there. These edges here turn down like this one. A 3-inch cheap hole saw, but allegedly it'll go through aluminium. It's only got to do 2 cuts. So with these, sometimes they jiggle a little bit, so the hole ends up a tiny bit more than 3 inches. So I don't know whether that's why they made them slightly oversized, I don't know, but you've got to be careful. It's got to be quite close because the lip here is quite big, but the lip here is only a couple of millimeters. You don't really, taking it really slowly. This is just part of the collection I've got of old aircraft parts. They're post-war, but I mean they were used during the war as well. So these were used in lots of British aircraft. I think the Lancaster had them, like super chunky switches, designed to be used with gloves. So this type, like a momentary, and down. They're commoner than this type, which have obviously already been picked by the pickers. These go like that, like that. And this is the key one. This thing is just a push button. So I'm thinking that's gonna have to be the ignition button, really, isn't it? Let's be honest. Now the only place I can put that, because it's so deep, is kind of there behind the steering wheel. This is the kind of educational bit of this video, and I filmed it and then lost the footage, so I'm doing it again. Basically, I've got a master cylinder, if you remember, attached to kind of generic, it's a generic master cylinder available off eBay, quite cheap, used in Land Rovers and things, and the fitting on the end of the pipe to that is 3/8 24 UNF. I've then got a 3/16 pipe running to the back of the car, T-splitter, then off to the brake drums. Now, working back from the brake drums, the fittings for those are 7/16 24, and they're for 1/4 inch pipe. So I've tried all different combinations. This is the simplest. So a male 7/16 24 male fitting goes into the brake drum. That's good. 1/4 inch pipe to the T. Same the other side. You can buy a T that's got 3 female ports, and they're all 7/16 24. So that's great. All I've got to do is find a connection for a 3/16 pipe that's 7/16 24 male to screw into there. Now you can't get that. I couldn't find one. So there's this adapter, which is a lifesaver. That's male one side, 7/16 24 goes into the T, and then female side it's 3/8 24 UNF, same as this. So what is this? This is the key to it all. It's called an Edelman adapter. I found it on a forum. It's called an Edelman 258340. If you enter that into Google or whatever and search, if you're lucky, you'll find one. I had to get it from the US, shipped over. So by the time it arrived here, it was really expensive. The T, not so bad. It's just 3 female ports, all that size. So that's how I've done it. And so let's see what that looks like. Actually, it's not that great. It's a bit lopsided, but you get the idea. Bearing in mind there's a beam axle here that's sort of bouncing up and down, I've taken this over here rather than lower down, and then it runs along the frame rail. Got brass P-clips for a bit of period sort of look, and copper rivets, or there might be brass. This is the handbrake system. Yeah, so there's the MG midget handbrake, and that all is now plumbed in nicely. It doesn't rub the tubes where it goes around them. There's a very small gap. It's deliberate. It goes through rubber grommets here in the bulkhead. Stop any chafing. Right, there we are. And then down again, so then I've got two pipes running along the side here. One then goes to this. Don't know if you can see it. Hydraulic cylinder there. Which I've got the right way up now with the bleed screw at the top. And that activates, if you remember my adjustable rod here. Sorry, here. Which pushes this arm back and forth. I've decided I'm going to make the end dome here last. So we transfer this to a piece of aluminium. It's cut very slightly oversized, but not too much. Right, as you can see, it's in the right place here, and I've tucked it under there. Right, you see that a bit dark here, but you can see that join is about as good as I'm going to get. There we are. Right, ready for being hit now. This down like this. So, pretty good. 14 chance of getting tack welds on. Yeah. Well, it's a lot neater than my previous efforts. So I've put two bracing struts in here. So that always ends up just under the edge of the top panel from the previous one. Well, that looks promising. There's about the circle, the wooden circle is about 2 mil narrower all the way around. The dome long enough, hopefully, for me to get some tack welds on. Well, that's come out pretty well. This is the top part. Got me to this point. See, I've got the welds pretty smooth down. So now I need to blend in kind of scuffs, if you like, with the rest of it. Almost invisible. Right, that's 240 grit in the polishing wheel, 400, then 800, very lightly. You can see if I do it any more, it's going to have a really shiny tail cone and the rest of the car is going to be dull. So I haven't polished it yet with a polishing wheel or any kind of compound, but I think I might actually stop at this point for now anyway. Just like that there. I could always weld a tab on there to push it out. Here's the maths for my car. Based on this Morelli guy's paper, the width at the widest point of my car is about 90 centimeters, and he found that the drag of a teardrop shape just falling through the air is 0.09, and it goes up to 0.14 if you're within 19 to 14% of the body thickness from the ground. So if you work that out for me, that means my drag would go from that to that just for the body shape. If I go lower than 8 to 12 centimeters from the ground, which fits with the solar cars, where the minimum height for many of the solar cars, according to the tables, is about 15 centimeters, but a lot of them ride a lot higher, about 30 centimeters above the ground. So my car is, I can't remember actually, I think it's about 10 centimeters off the ground at the moment, something like that. So ideally I should have it riding even higher, but there we are. But there's a gap here, so the idea is a radiator there with air going through it like that, and then there's going to be a panel which runs under the engine to about there, and the air is going to go in there, run along under the engine, and then out through the back of the car. And the exhaust is going to come down from the manifold and go in and fire sort of, my pen's running out, fire into the same chamber, sort of sucking the air with it. So I've got to make this panel, which is sort of shaped like that. Okay, there we are. So this is the kind of reverse buck for the underside of the engine. So I'm going to do this in one try to do this in two parts. So I'm going to look at this part. It basically is a flat piece of metal that just goes down in a V and then back up to match the V of the engine mount. Then this part, because the starter mode's here, remember, it's like a big dish shaped. It actually extends further than this into a sort of curve, which needs, with the jack, you can see. So I made some cardboard templates of the sides here, which is really difficult because you're dealing with lots of different curves. Then I did them in aluminium. So what I've done is I've just used tiny bolts for now in about 4 places along there towards the tail. Right, well, about 2 days of work have passed since I last filmed anything on this. So you can see I've welded all the way along here now. So now I'm just cutting out holes for the exhaust. So the manifold's here, so it'll go down. Instead of going 90 degrees then 90 degrees, it'll actually go in at an angle and then straight, which is why I've got an oval hole. Let's just show you it from the end. So from a point of view of getting the air out and the exhaust out, that's fine, isn't it? Right, you can see that the sliding rod, it clears the body by about 1 millimetre, and you can see that that ball joint there in the middle of the screen now, that also clears by, ooh, got a whole 5-6 millimetres maybe. If you remember from the engine test video on the test stand, this plug was leaking. I tried all sorts of things to sort it out. Some plugs seal down flat with like a crush washer, some have a bevel. But basically the surface is irregular there, so it's not going to work. And the thread is on the edge of pulling out all the time. So I'm going to have to take the head off. My cylinder head's come back, so check this out. So 8, 7, 6, 5. What's different? These are one of these AC Delco or something. Anyway, the Champion ones have the flat cross washer, which is probably easier when you're trying to machine things. So if you remember, it wasn't sealing, it was really damaged, corroded. I had blow by, you could see in the engine test video, a little puff of smoke. coming out here with each ignition. So he's made me an insert lock. It's stainless steel. If we go on the underside, trying to break the plugs. There, you can see it. Some shaving foam. All will become clear in a minute. This is shaving foam. Right, I've seen it recommended as a way of blocking off the smaller water ports. The shaving foam is quite good as a lubricant actually for the scraper. I've just been using a cut down scraper as well. I've also cut it down in length, so there's a kind of harder edge there. Shaving foam, so now I've given it once over a quick scrape. You can see there's quite a lot of goo, bits of gasket along there, mixed with a bit of rust here. So you just go like that, and as you hit a raised spot, it just shaves it off. I mean, so sort of like this. On that, so 55 is a generally agreed middle torque for cast iron heads. You're then meant to run the engine, warm it up, let it cool down again, retorque everything. Do that at least 3 times. This is my copper gasket. It's actually copper faced. There's a copper facing each side, and then there's some kind of composite between the two. So let's do that. So I'll put all these on hand tight and then start the torquing process. Put this in there, you can see. There's a little bit of leeway. I've made the hole slightly too large, so no doubt it'll be in the wrong place when everything's bolted up, but you've got to do your best, haven't you? So I did some research on high temperature exhaust paints, and in fact a lot of people said the stuff that's actually sold as high temperature exhaust paints doesn't last, flakes off. The 2 best recommended were barbecue paint, which I think is usually black, but obviously that's designed to withstand high temperatures. And then there's this stuff, Rust-Oleum hard hat. There we are, 2186. They've all, well, you can kind of see what I'm doing here now. You can see how that produces a really neat finish. Okay, so I think that's pretty good. I've got a reasonable even edge around there, and the bolts go in properly. So I'll try and show what I'm trying to do here. The edging strip here pushing against the top of the duct to make that join there airtight, so it's just pressing against it. It's not actually bolted to it. And then if we go on the other side, so the panel I was just making earlier, I was folding this edge on here. So you see this is a side panel which blocks off the side of the radiator all the way down. And you can see with a bit of adjustment there's an L-shaped piece bolted on. It makes a pretty good seal up against the duct which goes under the engine. Right, nothing will happen on the instruments yet because I've not turned them on. So now I'm going to flick the power switch, and then we'll see what happens now. So here we go. Oh, I'm nervous. No wonder there was no spark. Okay. Right. Oh, all right. We've got. This is just the self-test. Right, these are zeroed. RPM is, well, I'm almost at 0. I've got voltmeters reading. Now you remember it's not quite right, the scale, because I replaced the internals but kept the gauge. But basically 12 volts, look. I'll measure it with the multimeter, but whatever this battery is, it's probably a bit more than 12. So a normal voltage is just below the red sensors there. So actually look, you see it's more, 57. So where are we on here? Alright, we're around 50, aren't we? Right, so this sticks through the main body into the top sort of head fairing thing, so there isn't much room for an air filter. Now I can put one of those little round hot rod type filters on, but they're actually quite restrictive. I'll give you a link to a video about that at the bottom. So I could leave it open, but then I might get it full of sand. I could put something on it like that, faces backwards. You get less sanding because you're sort of sucking from behind. You can get some ultra low profile sort of things, even on regular cars, which have quite a sharp turn in them. So basically you want the smallest angle of turn that'll just fit under my head fairing. And okay, so the next thing is to put the fairing on and see if it clears it or not. It acts like a kind of dynamo. It's not an alternator. You kind of need something here with a pulley on it to maintain the tension on the belt to drive the water pumps without. You can't just have a triangular belt, for example, because it would run in across here, because it would smack into all the distributor electronics. So I've seen people just take this off and just have a pulley here, like an idler wheel, and just charge the batteries up at night. I think I'm going to fit an alternator. Now you can get an alternator that's been built into the casing similar to this, so it looks like a generator. And on some of the hot rods where everything's exposed, they do that. They are pretty expensive, I've got to be honest. So what I'm going to do is, and I've checked with the Vintage Hot Rod Association because I don't want to get told off for breaking the rules, but I use what's called a General Motors one wire alternator, and they're called a one wire alternator because basically it's the easiest one to wire up to the rest of your minimal electronic system. Comes with a pulley on it for a narrow modern kind of belt. So I also managed to get hold of, and the other thing I should say is they're reasonably priced. You know, these are a lot cheaper because it's been reconditioned, but they're made you know, in ginormous numbers, and they're still used in by loads of hobbyists. Again, probably because it's got the word one wire. So I've got a separate pulley, which is wider, and it's wide enough for this belt. I suppose I should just check that is the case. Yeah, come out with a slot in it, slides up and down, so it's nice and simple. Now, of course, that mounting isn't going to work for this alternator. So what you can get is a thing that's kind of Y-shaped. It's kind of shaped like that, like a catapult, with the slot in it there. So my laser cuts in thick slabs of steel just come back. So that's 15mm thick. I think that's 10. There's my preliminary sketch there, you can see. And yeah, so the idea is this goes like that. I've got the alternator sitting as low as possible in this cradle. You can see there's just a tiny gap there for the fins. I need to fit this because I need to test fit the radiator and create the hoses and make sure they miss this, even with a bit of flappage at high RPM. The fuel tanks come back. I went to get this morning from the Welsh Wizard. There he is, and he's welded on some mounting tabs for me because earlier on I didn't know where they needed to be. Here, yeah, on there. We've got the washers now. I'll take one of the washers. Roll away on this one again. So the roll is 4x5. So I've got the washers there. Get the washers. So that's the tank. The reason for the washers is don't you work cycle tanks. The reason they put there is with any slight flash, the chassis doesn't get to the tank. Just before you take it. Put the body shell on one last time to check it still fits with the washers. Tap 2 threads like you've seen me do many times before, and yeah, there it goes. Larger hose on the bottom and narrower hose on the top to the narrower fitting. So needs a little bit of a last minute tidying up, but that's the general idea. So you see this target here, basically this circle is where the filler cap is from the fuel tank. That will fit within the body shell. It's very, very, very near to level, and it just clears just this belt. Don't know if you can see there, if I shove the camera under there. The bottom hoses are in. The only tricky bit, because these sides come off, the only tricky bit was putting the hose through the hole in this panel, and then you can just reach that clip, which has to be done up to the right to miss this belt. So I've got one of these things here. It comes with a load of radiator caps and adapters. It's like a little bucket, you see. And the idea is you fill it with water and then you plop this in, and then you can lift it intermittently and sort of control the water as it goes in. Rather, I'm looking at the floor while I do this. Maybe it's not falling out at least, something. And it's fluorescent green. Yeah, the sunny starts dripping over here. Just filter the bread and I can put the plunger back in. So it's quite cool, can't it?
Go for landing. Retro. Go. Fido. Go. Guidance. Go. Patrol. Go. Telcom. Go. GNC. Go. ECAPCOM. We're go for landing.
Using the squeezy bulb on the boat tank, and last time you could actually hear the carb filling, so let's have a listen. You can hear it squirting in now. Okay. Yeah, there's a bit of fuel going down there. It's the fire suppression kit. I thought it said flammable compressed gas there for a minute. I was a bit worried. I was hoping it wasn't. Yeah, anyway, that's the next stage. Okay, so here's my fire suppression kit. Will the seat fit? If I've done my measurements correctly, it will. I've got it as far this way as I reasonably can go. Well, there's a bit of luck. It fits okay. There's my pull. Convenient spot, I think. The top part of my roll cage in this pale primer from Rust-Oleum, and then I've got this aluminium paint which resembles aluminium, T2115. So I did a test spray, so that side's aluminium, this side's the paint, and then I went for it, and on the actual car you can see it actually looks better on the car actually than my test, but you can see it's I don't know, it almost looks like it is aluminium. This adapter, which again, not pretty, but will do the job. So that should fit on there. Yes, it does. So there it is. It looks a bit weird, but it's an air filter, I suppose. So that's oversized at the minute, so just got it clamped in place. Cardboard aided design. So basically I want it to be that high in the middle and then kind of come down. This seems to work quite well. There, perfect fit. Fits here. I've trimmed all this back. I've got a flush fitting bolt there, so it's not interfering with this. This is flared up, you can see how it matches the curve. Look, basically you've got a pin, it snaps on, and this goes through your panel. Just push it, comes off. So if these were fitted to the acrylic on the inside, I could just put the screen in. At the sides I could just pop them on. But of course it's not just a case of drilling the holes and fitting them, because these are really designed for sort of like bonnet studs. I mean, I would prefer if that had been threaded all the way up, it would have made life much easier. So once again, like everything else on this car, I'm modifying things. You locate these first, loosely. Like that. Then you loosely do these two. The body needs a bit more trimming. There. All locks. And then these two lock. There you go. Actually take that much, so we'll just do this a little bit at a time. So I've wedged that in there level. Let's see if the seat still fits. Okay, well, it does fit. So put the battery in now and see if it's in the right place. It's a pretty good fit. Not bad at all. And that's great because that can come up, go through my bulkhead connector, which is still on order. Then that'll come round up to here and then join in with everything else I already made. Now I've done something small but quite important here. The reverse lockout. So what I've done on the gear lever, I've welded a slab of metal about 5mm thick to form an edge here, if you can see that. And then I've welded in this piece here, and it's got this, I'll put a link to this on the bottom of the video, but you can see, I can't remember what it's called, it's called a detente pin or a twist lock pin, I can't quite remember, but basically this pin comes out here. So what's that? Well, it's actually reverse gear lockout. So we're in neutral at the minute here. If we go down, reverse would be that way, but the pin stops it. Okay, so I've welded it in, so let's just see if it works. Yeah, pretty good. Right, so now I need to make a mount for this near the front of the car somewhere. So there we go, all neat. I mean, who taught you?
My father was a poster writer.
Ah, right.
So he did a lot of, in those days, adverts in the papers were done with by hand, you see? So he'd work with the papers as a poster writer. I started when I was 14, so I've done this all my life. Stick.
How do you spell that?
M-A-H-L stick.
Wow.
Yeah.
Oh.
So this just keeps my hand off the surface of what I'm working on.
I'm going to have to look them up now.
Yeah. You know, I can keep my hand off the paint.
Yeah.
And the last thing you want is paint in your hands, and then the paint then is on your hands, and if you touch the surface, it's on. You know, you get in a mess then. So
Yeah.
it's just really useful tool. Simple, but really, really useful.
I don't like this flattened end here. It needs to come out about another 2 inches. I know it doesn't seem like much, but it's a shame because I put so much time into the rest of it. So here we are with another of my dome hammering contraptions. Clamp between, and then move to my English wheel to smooth it out and make it look lovely. You can feel them bouncing through, so the aim is to smooth them down bit by bit, then slowly tighten it. You know it's coming, so I'll stop filming now, and then I'll do a bit more, and then I'll film again. 2 full passes with a fairly thick filler rod, because I want it to be proud, so I can use a flap disc to take it back. The other thing I've done today is smooth this off. I've not polished it yet, but I've used 120 grit. Now all the time I've been working on these, just sanding them and putting the bit of black, satin background, I've been thinking the same thing. These just remind me of something, and old movies, cheap B movies. Right, well I've finally finished the foam. So I've wrapped the foam in tape here before fixing it on. Makes it a little bit more sort of abrasion proof. I run out of tape, so I'm not going to do that or these, although I might do that in over the winter or something. I took the padding off the front bar. I was looking at a lot more pictures online, and yeah, a lot of people sort of pad it all around where the shoulder area is, head area. Got padding here right up to the front. So actually I tidied that a little bit up with an aluminium strip there. You can see it just tucks in each side, and it's held on with 2 rivets inside. Well, here we are. Right, so you can see from the wire fencing and everything from now on, this is also a military kind of test firing range. There's a bit of a clue here. Yeah. Report any suspicious bits to Kinetic Q. Kinetic Q is when they privatised the whole section of the Ministry of Defence. Many years ago, a few civil servants became very wealthy men. There we are. running and then it boiled over. 100 degrees. Driving it from the trailer to parking it inside the pit area took me up to 56 degrees, that's Celsius, and you have to get into the queue in your number order. So you sit and wait to turn in, and then you turn into the queue. So that was 4 minutes 20 seconds. By then I was up to 91. So you can see here, by the time I actually started my run, I was well over 90 degrees. I was probably closer to 100. There we are. Bye bye car. See you in a couple of days.